Assalamualaikum warahmatullahi wabarakatuh and a very good day to my Honorable Malaysia Technology Expo MTE 2022 judges. My name is Associate Professor Dr. Midhat Nabil bin Ahmad Salimi from the Faculty of Chemical Engineering and Technology, University Malaysia Police UNIMAP. Today I'm going to talk about my invention with the title of Carbon Capture by Eggshell Waste. This is also a research collaboration with Technology Tenaga Police Consortium or TTPC. So I would like to start with the problem statement of my invention, which is global warming. Global warming can be defined as the rising of global average temperatures. The effects of global warming include less snow and ice, more droughts and wildfires, warmer oceans, and rising sea level. Carbon dioxide's invisibility is what causes global warming. So the more carbon dioxide emitted, the more of this gas will trap heat, causing global warming. In terms of total CO2 emissions in the year 2017, the transportation sector contributed the most, which was 47%, followed by the industrial activities, which contributed another 23%. In terms of largest producers of CO2 emission worldwide in 2017, China led the list, followed by US, India, and Russia. So basically, the bigger the country with higher population tended to produce more CO2 emission. Shockingly, Malaysia was ranked at number 26 as the largest source of greenhouse gases in the world. Naturally, the emitted CO2 will be absorbed by the plants at an amount of 25%, and another 25% will be captured by the sea. So the remaining 50% of CO2 emitted will be remain in the atmosphere. My invention is based on eggshell, which is to be used for carbon capture. Eggshell or ES is an emerging abundant solid waste created from various sources such as poultry, homes, restaurants, and food manufacturing industry. In Malaysia, about 642,600 tons of eggs are produced every year, and from this amount, a total of about 70,686 tons of ES waste is expected to be generated every year. This waste has potential for producing hydroxyapatite with a chemical formula of Ca10PO4 6OH2, a major component found in bone and teeth. Hydroxyapatite has the big potential to be used for carbon capture. So the first step of my invention was to synthesize hydroxyapatite powder from eggshell. This was done by using the mechanochemical process, or simply by using the ball mill. Secondly was the process of converting the hydroxyapatite particles into solid sorbents or hydroxyapatite granules. This was done by using a wet-based granulation process. And finally, for the carbon dioxide or CO2 capture analysis was done in a tube furnace. From this process, the actual amount or the mass of CO2 capture was determined. As a result, hydroxyapatite granules absorb almost 4 times its weight in carbon dioxide or CO2. It is well known that carbonate ions can substitute into the hydroxy lattice by replacing both phosphate and hydroxy groups. Carbonate can substitute into two ionic sites of the hydroxy structure, one at the phosphate sites, known as the B-type carbonated apatite, and the other one at hydroxy sites, known as A-type carbonated apatite. In terms of novelty, this was the first reported of hydroxyapatite nanoparticle synthesis with control parameters by a mechanochemical method, which produce uniform and small particle size. This can be shown by the patent filing with the document number of PI 2014702579. In terms of publications, I had published several articles, some in very reputable journals such as Powder Technology, which is a Q1 journal with impact factor of 5.134. I also has an industrial collaborator, which is Technology Tenaga Police Consortium Sdn Bhd or TTPC. They had expressed the interest for research collaboration in terms of the ability of the hydroxyapatite granules in absorbing carbon dioxide produced at their power plant facility, meaning that using the hydroxyapatite granules for large-scale carbon dioxide capture. In terms of commercialization, the carbon capture market was valued at 4.4 billion US dollars in 2018 and is projected to reach 14 billion US dollar by the year 2025. In terms of the invention status, it is at technology readiness level TRL 7, which is system prototype demonstration in operational environment. As a conclusion, eggshell or ES is a natural waste produced in abundance yearly, which can be transformed into hydroxyapatite granules for carbon dioxide or CO2 capture application. This avoids of using synthetic chemical formation to capture carbon dioxide or CO2, which are less effective and costly. This invention can also be classified as green invention. This innovation also supports the Sustainable Development Goal or SDGs under Goal 13, which is climate action. That's all my presentation. Thank you for spending your time listening to my presentation, and I hope that you all had a great day and be safe and take care. Thank you once again.